Hello, welcome to lesson 1 of scale drawings, finding the actual dimension. Our goal, I can find the actual measurement of a scale model or drawing using 3 different methods. So we're going to start with some definitions. This says a scale is a relationship between measurements on a drawing or model or the measurements of a real object. So let's write that in. We're going to write in scale. And what we're given is the measurements of a drawing or model, and so I will frequently refer to this as the model. And then we also are comparing it to the measurements of the real object. So we might call this sometimes the actual. Next, scale drawings or models represent something that's too large or too small to be drawn at actual size. So let's write that as well. A scale drawing or model is just used to represent something that's too large or too small to draw or show at its actual size. Next, distances on a scale drawing or model are proportional to the actual real-life distances they represent. So that's why we have this particular scale drawing in our ratios and proportional relationships unit. So proportional. Now that we have more knowledge regarding proportional relationships, we will review several different ways to calculate the scale model measurement or the actual measurement. In fact, we can use 3 different methods, and you can choose which one works best for you. We will demonstrate this using past exam questions, so please take notes, and here we go. So this lesson is going to focus on finding the actual or the real measurements given the scale or model measurements. And we're going to show 3 different methods how to do it. And you can choose then on your practice problems just one of the methods, whatever is best for you. The drawing of a building shown below has a scale of 1 inch to 30 feet. So here's our drawing, and you can see measurements are marked. What is the actual height in feet of the building? And method 1 is to write and solve a proportion. So since we're going to be writing and solving a proportion, this scale and all the methods, the scale is very important. So what I want you to do right now is I want you to highlight or circle this information. So they're giving us the beginning of a ratio, a comparison of inches to feet. The question is, what is the actual height? And they're telling us that we're looking for, what we're trying to find is feet, which is the actual. So we're going to underline actual. That's what we're looking for, and we don't know it. So in math, when we don't know a quantity or a number, we choose to use a variable. So let's get started with this setup. I'm going to set up a proportion, and a proportion is 2 equal ratios. So I'm going to start with 1 inch. Now that would be on the model or the drawing, and it's compared to 30 feet. And you can see I can't represent 30 feet on paper. So this is the actual measurement. So now, because we're working with proportions, a proportion is 2 equal ratios. So I'm going to write equal. And now I need something that is inches. I need something from the model. And you can see they've given me 2 measurements. So I need to further read. It says, what's the actual height? So as I look at this, this is the measurement I need. So I'm going to write 1 25/100 inches. I'm going to label again, making clear that inches are on top, which means feet are on bottom. And if I look for another dimension, oh, I don't know it. In fact, that's what they're asking. What's the actual height in feet? So we don't know it. So we're going to use a variable. I'm going to choose x, but I'm going to make sure that I'm talking about feet. So now we have our proportion. So if you recall, When we have a proportion, we're going to cross multiply. We talked about the butterfly method. 1 times x would be 1x. The body means I drop down to equal, and then I'm going to take 30 times 1.25 in my calculator. So please pause and do that. So hopefully we all have 37 5/10. So now we're going to divide by 1, or we're going to realize that 1x is the same thing as x. So we have 37 5/10. So let's look back at what we found. Well, x is feet. They ask us what the height of this building is. So we're going to answer that question. The height of this building is 37 5/10, so you could say 37.5 feet. And I probably would have been better to include the word actual height of this building. So now let's go on to the second method. I want to use the same drawing so you can see you know what the answer is already. We're going to go through and see how we use other methods to find the same answer. Since this is the same drawing, we're going to use the same bit of information. We're given this scale. We're trying to find the actual height in feet. We're given this measurement as the scale measurement. And so you notice down at the bottom it says chart or table method. Mrs. Nord really likes to use this method, so I'm going to show you what she has her students do first. She has them start with the scale, and this is what we're given. 1 inch, 2, okay, it represents 30 feet. So if I used a table, you might recall that this would be the x and this would be the y. And so if we called this the inches and we called this feet, if we wanted to find a unit rate, we would take the inches and the feet, and I would take the y value divided by the x value. So this is very much related to our unit rate, and 30 divided by 1 would be 30. This is known as the scale factor. So we're going to call this the scale factor. So now that is what we're given on with the scale. Now the new information, what we're trying to find, is we know 1 25/100 inches. It says it right here in inches. What we don't know is how many feet. So we're going to use our scale factor and we're going to multiply by 30. We just found our scale factor is 30. So we're taking 1 25/100 times 30, which should sound familiar to you because we just got done doing that just a few minutes ago when we cross multiplied. So we'd get the same answer. So that's how you use a table method. And we'll demonstrate this a few more times. So we've used an equation in this unit, and we used y equals kx, or we could have written it like this. We could also write it as kx equals y. So we're just going to use a form of this equation, and we're going to use it as rm equals a. It's the rate times the model, and that's going to equal the actual measurement. So let's write down what each of these mean. The rate is actually the scale factor. We just found it. And we're going to find that by taking the actual divided by the model, our scale measurement. So we're going to take our y as the real and divide it by the x, which is the model. So that's going to give us a number, just like it did a minute ago. We called that the scale factor. Then we're going to multiply the scale measurement. So we're going to use the model measurement, whatever that happens to be. And then we're going to get the actual measurement, whatever that happens to be. So let's see what we can do with this. We've already found the scale factor, and remember, we're taking whatever they give us in the scale. They told us that 1 inch equals 30 feet. And the tricky part about this is we start with the actual, just like we do when we're working with a table. We start with a y, and we're going to divide it by the model. And so they said in this particular model, 1 inch equals 30 feet. So we're taking the actual divided by the model, and that's going to give us the scale factor. And again, in this case, it's 30 is the scale factor. So we're going to start with 30. We're going to multiply the measurement that they give us on the scale. And if you recall, that was 1 25/100. And that's going to give us the actual measurement. So if you recall, all three times we've gotten 37 5/10, and that's the actual measurement. And once again, if we look back, that is in feet. So 37 5/10 feet. So each one of these models has given us the same answer. So now let's move forward and try this again. So let's see how these three different ways to find an actual measurement could be helpful. And this particular problem kind of demonstrates why knowledge of these three methods might be helpful to you. Howard has a scale model of the Statue of Liberty. The model is 15 inches tall. The scale of the model to actual statue is 1 inch to 6 2/10 meters. So they gave us the scale. Which equation can Howard use to determine x, which we're calling the height in meters of the Statue of Liberty? So let's first gather all our information. They tell us the model is 15 inches tall. They tell us the scale is 1 inch compared to 6 2/10 meters. They want us to identify the equation that's going to help us determine this, and they want us to use x, and they want us to use x to represent the height in meters of the actual Statue of Liberty. So they've given us choices, and I can see that two of them are just straight ahead equations, and these are equations as well. They're just written as also we could call it a proportion, and a proportion is an equation. So let's start how we did initially. We're going to start building a proportion. So I'm going to start my proportion with 1, and that's inch, compared to 6 2/10 meters. Then I'm given this information, the model, 15 inches, so that's the model, so 15 has to go on top. This is inches, and that's compared to x, height in meters, so x meters. So because I just want to know which equation I can use to determine, I'm going to stop before I continue and see if I have that written somewhere. And sure enough, it kind of looks like this might be the equation I need to use. Next, you can see that there's an equation that's kind of written. These two equations are kind of written in this form. So I want to go ahead and confirm. We think right now that this is the equation, but we want to see how this compares. And I want to tell you that method 2 and method 3 are very much related. So method 2, I'm going to start with a table. My x column, this is going to be, in this case, inches. And my y column, this is going to be, in this case, meters. And here's what they've given me. They've given me a scale of 1 inch, and that equals 6.2 meters. So I'm going to use that to find the scale factor. And if you recall, scale factor is basically a unit rate. I have to take my y value, which in this case is 6 2/10, divided by my x value. So this gives me my scale factor, and my scale factor then is 6.2. So I'm using this 6.2. So now I'm going to take the other information they've given me. They mentioned that the model is 15 inches. So I'm going to put 15 inches, and we want to know what the actual measurement is of the Statue of Liberty in meters. So we're going to use that scale factor, and we go across the table from x to y, we're going to multiply by that scale factor. So the equation that we're kind of looking at right now is that 15 times 6.2 equals x. So if you want to look up above, if we look at what we see up above, we see 15x, right here, 15x equals 6.2. Well, that's not what we have. And we see 6.2x equals 15. That's not what we have. So those are not looking like they're going to work. So let's try one more method, our third method. Our third method requires us to use the scale factor, which we've already found. So where r is, I'm going to replace it with 6.2. That's the rate. And then the model measurement they gave us was 15 inches. So I'm going to replace the model, M for model, with 15 inches. And that should equal the actual. And we're kind of talking about the actual measurement. We're using the variable x because that's what they used here. So once again, if we look at these equations, 15x equals 6 and 2/10, or 6 and 2/10 x equals 15, that's not what we have written here. So we can then now eliminate these, and we already have chosen from the beginning what the equation is. Thanks for watching, and then please move on to the practice set.